Hello, ladies and gentlemen. Welcome back to math. Today we're going to continue working on transversals. Okay, we are still dealing with alternate exterior, alternate interior, consecutive, corresponding angles, or consecutive interior angles, and corresponding angles. Okay, two different words. All right, the objective for today is to find the angles measurement. Okay, using the four words we used last class, okay, which is alternate exterior or alternate interior, corresponding, consecutive interior angles, okay? Notice that I did abbreviations for the four words. Remember, we are still using those theorems, okay, to find measurements. All right, let's get started on today's concept. Notice that I have this chart. It looks so complicated, it's really not. We're gonna work on it together, okay? Make sure you write it down. We have two transversals. Actually, we have four transversals because they're all intersecting at least in 2 points. So they're all transversals. We have angle 1, angle 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay? We have a total of 16 angles. Our goal for today is very simple. All we have to do is solve for the angles. Okay? It tells us that angle 6 is 120 degrees. Okay? So we know that angle 6 here is 120 degrees. Okay? If we know that angle is 120 degrees, angle 6, by the theorem or the postulate, okay, which are words of your vocab, 14 is corresponding because they are both corresponding angles. So that means that angle 14 is 120 degrees. Therefore, if we know that angle 14 is 120 degrees, then angle 10, by the same law of corresponding, should be 120 degrees. Therefore, angle 2 is corresponding to 10 is also 120 degrees. Okay? So we use the postulate of corresponding to solve for at least 3 more angles with just one angle. Now we can use other theorems, okay? Theorems like congruent, adjacent, linear pair, symmetrical, they're all theorems you can also use, but today we're mostly going to focus on the 4, which is alternate exterior, alternate interior, corresponding, and consecutive interior, okay? By the law of alternate interior angles, okay? Remember, opposites on the insides. These ones are on the inside, if you're looking at it this way, but since we have 2 lines, you can also count it as the inside as here and here, okay? You can count this as the outside, or you can count this as the outside, okay? This middle stuff is always the middle, okay? It's a little more confusing when it's 2 because with 1, you just have one middle to focus on. This is why I chose a 2 to make it a little more challenging so you guys can see a little more of how it works, okay? So, if we look at alternate interior, we're going to focus on all the inside, okay? Alternate interior. We're going to look at it on the side. What's alternate exterior to 2? We can say 7 is alternate interior from line. We can also say alternate interior. We can even say 2 and 15 because they're opposites on the outside. But these ones are also opposite on the outside. Okay, on the inside, I mean. So there's different ways to look at it, okay? So we're going to use both the theorem twice. We're going to use it for 7, which is 120 here. then this is 120. Therefore, again, alternate interior, this is 120. Okay. Again, we can use it again. We know that. Just another color here. So purple. Notice that it's all coming together now. Notice that we have 120 here, 120 here, 120 here, 120 here, 120 here, 120 here. Again, by corresponding, back to corresponding, we can say that if 120 is 7, which is the angle, then that means that 3 again is 120, right, for corresponding. We could also say, because they're adjacent angles, these two are the same. The same here, because they're adjacent or corresponding from 15 to 11. This is 120. Notice how it's all coming together. We have all the 120s. If you remember supplementary angles, on supplementary angles, the angle has to equal 180, right? If you look at this angle here, let's say that angle. Okay, we erase the bottom. 9 and 10 becomes a supplementary angle, right? And this is your linear pair. So if this is 120, the 9 should equal the rest, right? To equal 180. So 120 or 180 minus 120. So 180 minus 120, we have 60. So we know that angle 9 is 60 degrees. Okay? If we know that 9 is 60 degrees, corresponding to it would be angle 1. So that's 60 degrees. Corresponding from 1 to 5, this is 60 degrees. And from 5 to 13, 60 degrees. What are we left with? We're left with 4, 8, 12, and 16. Again, congruency of angles, or again, the bottom is another supplementary, 120 and then the rest, which is also 60, right? So now we solve for all the angles. Our big angles were 120, our small angles were 60. And that is how we solve for angles using alternate exterior, alternate interior, corresponding, and consecutive interior. Okay? So here's your assignment. Alright guys, so here's your assignment. I have the exact same one, okay? I haven't changed any numbers. There's still 1, 2, 3, 4, so on, so on, so on. The only thing that I change is the measurement of angle 1 this time. Angle 1 equals 88 degrees, okay? So angle 1 equals 88. You have to solve for the rest of the angles. But here's the best part, okay? Here's the big part. Tell me how you're solving them. So if you're going to use 2, from 1, you're going to go to 2. Tell me what theorem are you using. If you're going to go from 1 to 5, tell me what theorem are you using. Okay? So explain a little what you're doing. Okay? Don't just write the answers in there. Tell me what theorem are you using as well. Once you're done watching the video, send me your answers, and I'll be waiting to hear from you.